Hi everyone, welcome to the Secure Developer. I'm really excited today because we have Siren Hofvander joining us to talk to you all about security and the software development lifecycle. Before we get started on that, for those of you who are new to the community, my name is Sam Hepburn and I'm the community manager here behind the scenes, making things happen. So any feedback, session ideas, things like that, please ping me. If you're not already on our Slack, it's the best way to ask Siren questions today. So if you head over to thesecuredeveloper.com and click join, you'll be able to join the Slack channel, join the live sessions tab, and then you can ask questions and interact with the rest of the community. If you are watching this session after the live recording, you can still pop your questions in there and we can try facilitate to get them answered for you. So please join us on Slack. The other thing to make sure your viewing is good, if you can go to the cog on the bottom of your screen and turn that up to max resolution, it's the best way to view today. But other than that, that's enough from me. The session will be available on the Secure Developer website a couple hours after it's broadcasted. And other than that, it's enough from me. I'm going to hand over to Siren. Hi, Siren. Welcome.
Hi, Sam. Hi, everybody. So this is like my first webinar where I can't see anybody but Sam. So I'm sitting in a room by myself, like talking to myself like a weirdo. So if I seem a little bit weirded out, it's just because I've like never sat and like ranted like a true crazy person by myself in a room. So I didn't prepare any slides today, and I'm not going to be demoing any tools at all. And I'm not going to be talking about any frameworks or languages. And I know that like 90% of you are like, I'm out. But the reason I'm not is because I want to talk a lot about the development lifecycle itself. And that's from birth to death, which should be like language and tool agnostic. And when we're looking at security, we want to have kind of a baseline level of hygiene as opposed to having, as long as you use this language, as long as you use that language, you're going to be fine. And my experience, and I talk at conferences a fair bit, is that we get a lot of people that are like, I wouldn't do that because I don't use that language. I'm front-end, back-end, mobile, serverless. I'm SRE, that's the new buzzword. And so they kind of turn off their brain, or they're looking at somebody exploiting a bug or demonstrating a vulnerability where they personally feel like I wouldn't make that mistake. And this is where I get a lot of people talking to me and being like, well, I'd like to learn, but I don't use that language. And so you've kind of missed the boat because it's not a language that's the problem. It's kind of the concepts. So that's what I'm going to be talking about. So if you're expecting slides, just like imagine a funny photo and like just imagine it with me. So I'll be thinking about a funny photo. You can be thinking about a funny photo, and we'll be good to go. But a little bit about me. I do secure development, but I don't actually write code. I can't. My brain doesn't work that way. I've tried and tried to teach myself how to code, but I can't. I can script and I can read code. But what I've kind of realized is my niche is working with developers to help them write better code. So that's everything from code review to picking up your dry cleaning to getting somebody's coffee and to try and make that process a little bit easier. So what I want to start with is kind of the idea of security in the development lifecycle itself. And when most people think security in a development lifecycle, they think pen testing, because this is what a lot of people's experience with security is. It is the end result. It is somebody attacking a system. And this is where we get a lot of security tooling for, OWASP top 10, find your vulnerabilities, find your exploits, find your whatever it is, which becomes really, really problematic because I've never met a developer that's just a pure developer that's learned how to do that by how to break things first. You learn how to build things in a secure manner. Secure here being it works, it's on. You can see a front end, your back end is on. Something is talking to something else. So secure in this perspective is it works. And this is where you can look at building a house. If I were to build a house in an area that's really hurricane prone, I'm going to know that's a hurricane prone area because I'm a house builder. And so therefore I'll be building my house to withstand a hurricane. I won't know if it does that until a hurricane actually shows up. But I have to take those environments into account when I'm building my house. Does that make me a secure architect? Probably not. It makes me a decent architect. But when we're looking at security, we come at it from an attacker's perspective. Why do we do this? Because the attacker's perspective is more buzzword media friendly and it sounds cooler. So it becomes an easier, and I'm sorry if you're a salesperson that this is going to sound really insulting, but it makes it easier to sell because real security work, honestly, it's not as flashy and sexy. I think it's fascinating. And my hope is that other people can find it fascinating with me. But being like, we're going to have a base level of hygiene with like a solid unit test baseline, or we're going to attack your system, think like a hacker, you know, yeah, it's the commercial for like cleaning the bathroom or like attacking the system. I know which one is going to draw more clicks, and that's where most of sales goes. Where can we get in the money? So putting all of that aside, what does real secure development actually look like? So on Slack, Sam, you can kind of raise a hand. Does anyone actually like know? Does anyone have like a good way to like phrase it? I'm not looking at the Slack. I'm just like staring at myself like a weirdo. So I don't actually know.
There'll be a few seconds behind us. So let us see if anyone knows.
I'm going to go with no. Okay.
Simon on the channel says he feels it's different for different people.
That's actually a really, really good answer, and I'm really stoked about it because I think this is where like our first stumbling block comes in, which is why I didn't want to talk about tools or language, because it is different for everybody. And so the security that you're going to be offering to a back-end developer versus a front-end developer is not going to be the same type of security, which means the things that they're going to be focusing on are completely different. And it also assumes that everybody is going to have the same kind of level of effort, the same type of passion. And let's be honest, passion is a privilege. But when we're looking at security, nobody comes to work thinking, I want to do a bad job. No one comes to work being like, you know what, I think clear text, MD5, you know, having no throttling, all the traffic, all of the time is a good idea. Like nobody does that. But where one person may think, you know, encryption and you know, validation frameworks are really interesting, the next person doesn't. And so you have to make sure that you have a base level hygiene factor that caters to everybody. Because looking at what good security is, it's actually the idea of making it easy to make the right types of choices. And this is where we can look at something that Apple's done, which is Face ID. Now, when Face ID came out, there was a lot of, you know, Twitter, oh my God, Face ID, North Korea is going to hack my face. And there are a lot of really frightening articles about the idea of a 3D mask. You know, somebody can make a scan of your face and then they can get into your phone. And I would just like to wonder, like, how many people is that a real risk? Like, if you're a high political person, if you're some sort of, you know, really important someone where you have a lot of information on your phone, that may be something you can take into account. Me personally, that's not something I worry about on a daily basis. Where my mom is a really good example, because even though I've been her daughter for all of my life, she'd never had a lock on her phone because she's not good with numbers and she's not good with remembering PIN codes and things. And so for her daily life, having a PIN code on her phone was such a problem that she didn't have one. With Face ID, she actually has secured her phone in a way that works for her. Does it mean that my mom is not deserving of a level of security? Absolutely not. It means the security has to change to fit the reality of the person using it. We can see this a lot when we look at development because we're catering to, okay, so you have to have, you know, these super heavy requirements. We're looking at two-factor authentication. Two-factor authentication must be on everything. But if you're a small startup and you have to get a lot of customers in and your two-factor is killing your conversion rate, if your conversion rate is directly resulting in you getting salary at the end of the month, does it have to be two-factor authentication on all of the systems? Can you use something like device tokens instead? Could you use better session management? So it can't be just kind of a blanket, you must. If we're looking at security from, you know, the dawn of time where you have the compliance person in the suit, We are the department of no. And this is where a lot of those types of fears come from. I meet a lot of developers and they're like, oh, I want to go towards continuous integration. I want to run agile. I want to have an autonomous team and make my own decisions. But I fear security showing up and saying no. And this is where we come back to the idea of we have to have a different level of security for everybody. So it's more the idea of how can we empower developers to make smart security choices. You hire smart people. So security's function is actually to empower them to make smart choices and bring up the idea of visibility. So most developers do a lot of security work already. Most developers know how to implement HTTPS. Most developers know how to implement an encryption standard that isn't MD5. Most developers can identify spaghetti code when they see it. I don't know if spaghetti code is like a global thing, but it's basically crap code. Most people know where, if they're integrating against a service and it's been built by, God only knows, that's not a system I want to touch, or you have to make sure that you have this one particular setting in this one particular area. So you may have some extra redundancy. All of those things are actually security requirements that are already being done. But because we've had this red team offensive, we're going to be attacking systems, all of those things aren't actually identified. So when we're looking at development lifecycle PIDs, one of the very first things you want to start looking at is what are the security in the tasks that I'm already doing? And this is where we're going to get to the first tip of the day. Ta-da. There are a lot of really good standards out there. You can have NIST and you can have SANS, but the one I actually want to highlight is one called ASVS and MASVS. And they're two requirement standards. M is for the mobile and ASVS is not, obviously. They're on GitHub, you can fork them. And there are a bunch of different types of requirements that are automated tests and requirements built in, and there are 3 different levels. So if you are a developer that you're working on your authentication schema, you can look at something like ASVS and pick out, oh, but I already check that all of the pages that are behind login, that you actually have to be logged in to view that page. I actually check that when you're logged out, if you have a round robin setup in your server environment, that if you log out on server A, server C that handles the logout function will tell server A, hey, we're actually logged out. So it'll actually clean up your sessions in a correct way, rather than kind of being like, I have to find a bug. This will give you, these are the actual security requirements at the technical level to not only increase your own confidence in doing security, but enable you to talk to the security department in a way that is their language, that gives you kind of the ability to push back. Because this is where security and developers need to be on a more equal playing field, because so often we're coming at one another from an adversarial perspective. Security shows up and, hey, we're not using these tools, we're not using these standards, therefore you're doing nothing. And they're meeting developers that are already working 40 hours a week. How can we then have a positive relationship if 40 hours a week, you're not using these tools, therefore you're not doing anything? That's simply not true. So one of the first things I always tell developers is help me to understand the things that you're already doing. Great, so we're using a known encryption standard. We already have a good understanding of how we're handling keys. We already have a good understanding of the integrated services and how we maintain them. We already have a good understanding of our packages. We already have a good understanding of all of these things. Let's make sure that those things are visible first. And then it's you and me together, the developers being my left hand, the security being my right hand. These are my slides. Hello, hello. Let's make sure that we kind of have a meeting of the minds so that the compliance or the regulatory or the security risks that I'm trying to handle, that you can help me to meet those. Okay, so we can't have the standard NIST recommended whatever it is in this particular area, then we can look at something like risk acceptance. How can we together, security and developers, make the business aware of why that isn't possible? And so that becomes an accepted risk from the business. And if it is not an acceptable risk, then let's use security's big stick, because we do have one, to make sure that developers actually get time to fix it. But it's a two-way street. Because if you're approaching it from, security is only here to make our life awful, and security is approaching it from, you're not doing it in this standard way, therefore you're not doing anything, that is never going to be a productive relationship. But to have that conversation, you have to make sure that the developers have the ability to actually gain the confidence to have that conversation in a productive way. And this is where something like ASVS or MASVS becomes really, really helpful, because it's really granular and it gives you the ability to say, okay, so we're at a level 1 right now when it comes to our requirements and our testing, but the data type or the type of business we need to be at a level 3. These are the steps that we can take to get there together. And it will mean that we have to have, X amount of more hours, X amount of more people, whatever the case may be, more coffee, more whatever the case. And then you can bring that to your security department and get assistance with that particular area. But it means that you're having a productive conversation of security has a job to do. Developers are already doing part of it. Let's find a creative way to solve that problem. So, step 1, visibility. Step 2 is still visibility. The next, I know, it's a weird stepping process. So when we're looking at security, a lot of the times the security team isn't the team that's built the first line of code. They're being brought into an environment that's existed for 1 year, 2 years, 5 years, 20 years. And so all of that code is not in the most beautiful, amazing, it's all been refactored, it's all been kept up to date, it's been maintained by, it's not. 90% of it is probably like, oh God, don't look at it because we found the new cool library. And so we're keeping it together with nuts and, bolts and tape and the hopes and dreams of small children. And so that can be really, really scary if you're looking at it from okay, I'm a developer, I've looked at these standards, how can I make an effective difference? Because now, I've waved my hand in the air to say I'm doing something, but 90% of what I'm working with, if you breathe on it too hard, it will fall over. And that can be really, really difficult because you only have 40 hours a week that you're paid for. I know that some people are, evening and weekend warriors, myself among them, but I try and also encourage a healthy work-life balance, which means that 40 hours a week, people. So how can you make an effective difference? So, I could validate all of my inputs because that is truly the thing you can do best. But if you have 10 million input fields, doing those one at a time can be really, really hard. So how can you actually make an effective difference? Because otherwise it can definitely feel like screaming into the night. And I have been there and I have felt that darkness, and it's a scary place to be. And so this is where you can look at something like threat modeling from a visibility perspective. So how can you use something like threat modeling and risk assessments to look at legacy code in order to kind of prioritize what you want to be doing? Now, I know that probably somewhere in one of the Slack channels, some developers sitting there being like, you're going to ask for an architectural diagram, and I release my stuff 80 times a week, and documentation gets dusty, and I don't want to do it because it will be, legacy the instant I write it. And you're absolutely right. I am not going to argue your point at all because you're completely correct. This is where you have to say, how can we keep an architectural diagram in some form up to date? There are a lot of cool things that you can do using a service like ThreatDragon, where you can check in architecture with your code. You can also have architecture diagrams on a Post-it note. So this isn't something that needs to be, it must be in this particular way, but in some way you will have a larger drawing of the system in some form. And if you don't have that, this is where you can run to your security department and get their big stick and take this fight together, because that larger architectural diagram will be in a lot of their work for a lot of privacy assessments, a lot of data protection and impact assessments, a lot of Article 30. A lot of their work will require a larger architectural drawing and a larger architectural understanding. And so if you don't have time to do that, this is somewhere where you can kind of collaborate with the security to make sure you have that time to actually get it done. That being said, don't let the security department run you over with, it has to be a diagram and it has to look like this and it has to have all of these parts, because continuous integration and security at speed is where we all want to go. So therefore, no developer wants to spend 3 hours a week maintaining a documentation stack. That's not realistic. But there are a lot of good creative solutions, and we're all very smart people. So how can we find a good way to actually do that? This is where you can look at a tool like SecurityRat, which is an automated security requirements tool that you can check into your continuous deployment pipeline, where you've identified assets and you've identified risks and you identify the requirements that are associated with them. You can also check in, architectural diagrams in something like that to keep it as a living document. You could look at having threat models or architectural diagrams in your YAML configuration files. You can look at having, a whiteboard that's online that everybody has access to, that during your, Friday beer, that I'm assuming basically all companies have a Friday beer. I don't drink myself, but I've understood that this is like the new thing. It's that and ping pong. I don't drink beer and I don't play ping pong, but I know that these are the things. Have a quick look at the whiteboard and add a smiley face. So make sure that you're not getting bogged down in it has to be this, but having an architectural view will enable you to say, okay, so we have 90% legacy. You're saying that we have to make a substantive difference. How can we do that together? And a lot of the time, the answer is going to be you can't. And this is like me not being doom and gloom. It's the reality of the situation. You only have 40 hours a week. You still have to keep producing things because the business case of we're fixing old things, old fuck-ups that we made 20 years ago isn't going to be great to drive in more customers or clicks or whatever the case may be. Therefore, you're going to be looking at something like mitigations. Now, this is where you're going to be expecting me to bust out a crystal ball and look into it and say, if we don't fix this in 6 months, we will be attacked. And we may or may not be, and I am not going to say that. So rather than approach this from in 6 months, something may happen, look at it from an architectural perspective. Given that we have a problem state of 90% legacy, what can we do to keep the 90% legacy from biting us? Because no one wants to come to work and be bitten by mistakes that some other developer made. And it's always some other developer. Even if it was you, I'm going to give you the space of it was somebody else. That how can we make sure that's mitigated? Because we're never going to have time to fix all of those mistakes. It's the reality of the situation. But what you could do is let's bring in some consultants to do the crappy refactoring. Let's have, a week where we all do it together with pizza. Let's figure out how to make sure that if this falls over, it won't hit us as hard. And if it's not possible, and in some cases it's not, it's just a shit sandwich. Sorry. I'm so sorry. I swear. I'm so sorry. I am very unprofessional. I'm also here in a onesie. If you're wondering what I'm wearing, I'm literally wearing a onesie. See? Yeah, it's all professional all day. How can we make sure that the business is aware of that? Because I think there are few things that are as horrifying as being the person that knows that, the problem is over there and feeling like that's on you. So this is where you can go to, sorry, was there a question or were you just kind of breathing at me?
Yeah, no, actually there was a question. I didn't want to stop your flow though. We actually have a few questions. So Bram has asked, he wants to know what your opinion is on the best way to find sort of budget for time, resources, people to get the development team even started on secure software. And sort of following from that is how do you even change the mindset of the developer to make them want to start writing sort of and delivering secure code?
So I would say they already are. And I think this is where like the big mindset comes in because everybody already is. And one of the biggest challenges is you're coming to developers who don't know what secure code means because they think it's something else. It's not. It is, HTTPS. It is making sure your keys are handled correctly. It is validation inputs. And a lot of developers are already doing those things. It's giving them the ability to see that those are real security improvements. We saw this a lot when, performance, it used to be something that another department cared about. Same thing with testing. It was somebody else's problem. Same thing with operations and deployment. It was somebody else's problem. But now we have DevOps. We have kind of a more focus on developers doing testing. We have kind of performance in the natural development lifecycle. So I would say the first thing before you even get to kind of writing secure code is you want to switch that to what are we actually doing? Hey, we're really good at making sure that our ciphers are up to date. We're really good at handling our certificates. We're really good at these because that way, rather than approaching it from we're doing nothing, it's let's build on the things that we're already doing. Okay, so we don't actually know how certificates and the PKI works. Okay, that's great. That's an educational improvement that we can make. We have a PKI system. How can it work? Let's hire in a consultant. Let's do a class. Let's read a book to learn more about PKI together. But it's already there. It's already running. So clearly we're not starting from, square zero. It's like 0.5. Because that approach means that you're going to somebody and saying, you're already competent. You're not a complete idiot. Let me help you get better at what you're already doing. Because that's a much easier conversation than you have 40 hours a week. Now you have to do something else. So it's you have 40 hours, you're still going to have 40 hours, but now you're more confident because you're doing security stuff too. And it's the big buzzword. Does that kind of answer your question?
I think so, yeah, definitely. And sort of following on from that, and a little bit about what you touched on earlier about sort of speaking to the security team, we have Brian who asked, do you think the security people need to code, in your opinion? Our last speaker actually advocated for this quite a bit. So, like, what's your opinion on, does security need to code?
I don't. I think that security people come in all shapes and sizes. And I have security developers on my team. I have a security architect on my team, but I also have people that don't code on my team very specifically. What I hire for first and foremost is always empathy, because our job is to be a supporting function. And we're a good supporting function by being empathetic and helping other people to do their job better. That can be having somebody on the security team that loves documentation if you have a lot of compliance, like GDPR. Having someone on the security team that thinks documentation is the best thing ever, saying to your developers, all right, talk to this person for 15 minutes a week and they will do all of your documentation. That's a huge win. Having someone on your team that can write, security automation tests is also a huge win. So I would say it's a mistake to say that you can only do security if you code, because that's saying that the only thing of value to a business is code, and that's simply not true. But depending on the types of developers and what their needs are, it may be a really important skill. But you also run the risk of, you have a developer core that would really like to have security as a focus. You might have someone that would like to get into the field. Having someone that does security code might strip them of that ability and lower their own ownership in the field. So I know that's kind of there's a trend of saying you don't do security if you can't code. I would argue I've been doing it for 12 years. And I don't code. I can script really well, but I can't write code. But I've been incredibly blessed to be surrounded by lots and lots of developers who can. So I see myself as a part of a larger environment.
That is all the questions we have at the moment. So if you want to carry on.
Yes. So we were on threat modeling. So we've got a threat model, and then we have a long list of risks, like these are where our demons lay. This is the legacy that we can't take care of. This is also where developers can kind of come together with their security team and say, okay, so we have our 40 hours, we can't fix this, and you're telling us it's a big problem. Do we run screaming to a pen tester? What is the next natural step? The next natural step is actually going to risk acceptance, which is not code related, because the developer and a security team boots on the ground, they're not the person that says, this is an acceptable risk. That's the CEO, that's the COO, CIO, someone with, that has a high pay grade or a lot of letters in their title, or is just, the first person to slaughter, needs to accept it from the business perspective. Because otherwise it's developers taking decisions that they don't have the ability to fix. And this is where it kind of leads back into how do you get people and budget? This is where people need to look above code. I think it's Kevin Henney. His last name escapes me, but he says that good code is from the wire up to the person. And I think a lot of people kind of get bogged down in, the business doesn't care about security, but the business isn't aware of the risks they're actually taking. So once you have a good understanding of kind of the larger picture, make sure the business understands that. If you have someone in your team that's good at business speak, that's good at PowerPoint slides, don't call me. I'm not that person. If you have someone in the security team, or if you have a team leader or a project leader, make sure that they can present that topic so that someone of the right pay grade says this is okay. Because otherwise you're going to have the business saying security is super important, but not important enough to invest time, money, or effort or people into it. So it's going to be a developer who can't hire another person, despite how much he or she may want to, knowing about a problem and feeling ownership for the problem without actually being able to solve it. And it's a crappy, not fun, codey way, but it means that if the business says, hey, we're not okay with 98% of our product being built of, the hopes and dreams of small children, that's fine. Then they need to give the developer core 8 more people, 8 new tools, lots of training, whatever the case may be. But they can't, on the one hand, say it's important, but on the other hand, say not important enough to actually invest. And that can't be a developer decision, which goes against kind of the new trend of, autonomous teams. But autonomous teams also live in a larger environment. Autonomous teams often aren't in charge of their own budget. They're not in charge of, business goals and strategies. So it's not to say they're autonomous to the point of they're running the business by themselves, but autonomy can also be ownership of, this is where our ownership stops. Our ownership is handing it off to the next person. So I know it's not like cool and we're all doing our own thing and startups and kombucha and ping pong. But if we're looking at burnout, which is a real problem within the security community, burnout comes from, hey, I'm highlighting the same problem over and over and over and over again, and no one is listening to me. Make sure that when you're looking at that void of legacy and spaghetti code, that your first option is always to give it to somebody else. It's a stinky mess. You don't want to just give it away as a stinky mess and be like, peace. But say, here's our stinky mess. Here's our plan to fix it. And if they say, we're fine with this stinky mess, your butt is free because you've sounded the alarm. If you're not the person that's head is going to be cut off, then you've done what you can. And I know it's not very, startup-y of me, but it means that you're not going to be sitting there with, 3 a.m. I know this is a problem. It's all down to me. This is where you can look for a healthy security culture, because what you want when you're looking at development lifecycle isn't, I found a problem and the business doesn't care, because that's rarely the case. More often the case is the business does not know, which is a solvable problem. It means that you as a developer have to be able to communicate with somebody in a way that they can understand. If this is risk and risk acceptance and risk management, it may be the security team is your best ally for that conversation. If they only speak in slides, find someone that can do slides, but make sure that that conversation isn't just down to the person that can't fix it from a budgeting perspective. So now we're getting to the coding bit, which now people are going to be like, but you can't code. And you're absolutely right. I can't. But I don't have to, because most people are already doing a lot of secure coding already. And this is where we can look to, what does that mean? These are the standards. These are ASVS, MSVS. OWASP has a lot of really good ones. NIST, SANS, all of those things. A lot of the code that you're doing is already secure. If you're looking at, microservices. Microservices, one of the biggest problems is networking and traffic. It's a denial of service. But because you have a distributed services all over the place, they're going to yell so loud that they drown one another out and kill one another. Most developers, when they're new to the game, don't realize that and immediately kill their own backend, because it's only going to call home, every 5 times a minute. They fall asleep, it's 500 times a minute, it gets deployed. Now there are 500 things calling the backend 500 times a minute. No, the backend isn't going to survive. You make that mistake once or twice and you won't do it again. But that is, a developer denial of service attacking their own system and learning from that mistake. You don't need to have, a special sticker to learn from that mistake. What you may need to understand is the wording that makes that more understandable, which when you're looking at how secure coding is taught, most of the time it's not, which becomes problematic because now you're at your work, you don't know about the standards because you haven't seen my awesome talk of me in my pajamas. And you look at something like OWASP top 10, which is what most pen testers are looking at. They say, we've run OWASP top 10. We found SQL injection because it's still a thing. For the love of God, if somebody could just write to me and explain how it's still a thing after a million years, I do not understand. Anyway, but if you're a front-end developer, that's not actually going to be relevant for you. And when you're looking at something like a cross-site scripting bug, even if it is your code, you're going to be sitting there saying, I only had 40 hours a week. It had to be there because I had to do this because I had no choice. And a lot of the times you're going to be right. OWASP Top 10 as the bugs, they are a result. They are the result. They are the end of the life cycle. So what you actually want to look at is something called OWASP Top 10 proactive controls. So if you go to OWASP, they have a list of proactive controls, which are the things that are supposed to be keeping the bugs away from the system. So these are the things that you can build into the system to keep the bugs away. So going back to my hurricane house example, you want to make sure that I have no idea how to build a house. So I'm just going to be wildly lying here. That like the frame of the house is extra sturdy. I'm not exactly sure. It's raining today, so I'm going with hurricanes. It's not a hurricane, it's just raining. But these are the types of things that, hey, if you have, you know, a critical asset, you may not want to deploy one, you might want to deploy multiples of it. If you have, you know, a key that's been compromised, how are you going to handle a new rekey distribution? If you have a certificate that's been poisoned, how are you going to handle those types of things? All of those are controls that make sure that the bugs don't happen. Most developers, all developers, I would say, don't want bugs to happen. So looking at it from once the problem has already happened isn't actually helpful, because that means that, okay, for the one input field in that one situation, I won't do that again. That's not helpful, and that's not how you learn. You don't learn coding by, okay, so you have to learn all of the examples for all of the situations all of the time. No one does that. You look at it from an architectural and a control perspective. When you're calling this type of API, these are the types of things that you're going to be looking for. So looking at something like proactive controls instead is actually a way that you can say to your developers, all right, these are the areas we're going to be focusing on. Now, this is where you want to make sure that you have talked to the business about it, because if they're saying security is important, how many minutes a week important is it? Because if it's a new topic and it's not any more minutes a week important, then it's not important. Now, no one can like okay, fine, you can misconstrue me, but please don't. That doesn't mean that you can like get up on your barricade and like, if I don't get 8 hours a week, security isn't important, the business doesn't care. That's a ridiculous argument, because most people are already doing security work. But if it's a new topic, if it's a new area, you have all of the right in the world to say, I want an extra half an hour to read up on how to use canary tokens, for example. What does a canary token mean? How can we use it in this system? How can I learn how to do that? Because developers do this with new frameworks, they do this with new libraries, they do this with new integrations. They can do it with security as well. What they need to be able to do is find the words to integrate it back to what they're already doing, as opposed to being like, I want to do it because security is important. It is, but it's not specific. It's, we're doing this, this is our focus area, these are the technical controls that I'm going to be using, these are the frameworks I'm going to be using, this is what I'm going to be reading up on. This is also where you can use your security team. How many minutes is it important? The security team can be like, hey, we have, you know, compliance, you know, we have a risk here. They can help you make sure that you get those extra minutes. They might have, you know, on my team, I have security architects and security coders that can do paired programming. They can bring in, you know, technical mentorship. They can have security champions. They may already have somebody that knows that can teach you. But it's still giving the developer the ability to say, hey, this is what I would like to do from a proactive perspective, as opposed to, hey, someone beat me over the head with a mistake that I probably didn't have the ability to change. So now you've done your coding in whatever language, using whatever fancy framework, you know, React has done its thing, whatever the case may be. And now it's been deployed. And now we're at the latest buzzword, which is SecDevOps. But we don't have DevOps anymore. I think it's SRE. And now it's SRE and SecDevOps. And I'm sure there's some new one. Buzzwords make me a little nauseous. And so now it's the idea of, okay, so you do a deployment and then like SecDevOps, like add, like stick some security onto it somehow. And this is the exact same thing again. DevOps already does a lot of security. They know what is deployed. They know what a secure deploy is. They know what can be deployed, what should be deployed, and what packages should make up a deployment. If it's a new sudden package, they will be aware of it. So having the idea of, oh, a secure deployment, I'm not exactly sure what that is, but I'm sure there's some marketing material that makes it sound a lot fancier than the configuration shouldn't be changed by somebody that doesn't work here. Our keys should not be in GitHub. Clear text is not a good idea. the sessions should log out when they say. All of these things are configuration issues or security issues that are not particularly fancy. You can hear my lack of marketing background here. But it's still the idea of it's not something that should be tacked on. It should be, we're deploying what we say in the way that we say it, and we're not just throwing it over the fence to the next person. But now it's in production. At which point does the developer's responsibility end? And I would argue yes and no, because I'm security, so I'm I'm in the world of gray. And this can be kind of odd because is it only relevant once the system has been attacked from a security perspective? And I would argue no, because security has a lot of functions that are supposed to make it more secure. But I would like to be paid at the end of the month. And if the security is so onerous that they're picking our competitor's product, I will not be paid at the end of the month because the company will collapse, and that will make me very sad. So this can also be looking at the controls that we have in place. Are they actually improving the system? So how can you actually do that? This is where, I don't know if all of you have seen it, but everyone, if you look at like classic security reports, there's going to be a graph in it somewhere, or like a box, and it's going to be high likelihood, high probability, and it'll be a red box. And in the red box, it'll be some stuff that you should do. At which point, security consultants will bust out a crystal ball and say, we should invest in this area because it is in the red box. And then you'll invest in the area. And if nothing happens, was it a good or a bad investment? You have no idea. If something bad happens, did you not invest enough, or were you unlucky? You also cannot know. And it becomes ridiculous, quite frankly, because you're making a bunch of investments with no actual way to measure or understand what you're doing. So you can look at something like risk forecasting instead. And I know it's going to be machine learning, and I'm so sorry because I know that machine learning has been done to death. So just sorry. You're going to want to look at something like, these are the controls we're actually applying in production. These are the things that our developers have built, looking at where we are now, looking 6 months ahead of time. How likely is it that the legacy that we brought up in our threat modeling is going to bite us if we don't change anything as of right now? And if it's 100%, okay, what are the steps that we can make to make sure it doesn't bite us in the next 6 months? Let's map those out and let's make sure that they're on our roadmap in whatever form it is. That way, in 6 months, when you're looking back, if nothing bad happened, the proactive steps that you've taken together have actually reduced the risk in a way that can be measured, as opposed to crystal ball gazing into the distance in some sort of like, whoa, because you're doing it together, as opposed to this is a red box that is unclear. You can do it with machine learning. I'm not going to talk about machine learning because I am unqualified, frankly. And the people that did my machine learning for risk forecasting will probably watch this and laugh at me. So no, but it can be done. But 2 things, and then I'm done. Where does pen testing come in? Because I've mentioned it, but I haven't actually talked about it. Pen testing is the result and the validation of the life cycle as a whole. So you've done your visibility in the first 2 steps. When you're looking at pen testing, they may have to do WASP Top 10 from a compliance or a due diligence perspective, but you can also be, hey, our developer core in this particular section, we've really focused on, making sure that our session handling is secure. Can you help us to pen test the session handling specifically, looking at these things we've focused on to validate that work? Can you come in from a security architectural perspective and look at our risk models to see if we've missed anything? So rather than kind of having a broad sweep attacker perspective, make it a directive or make it a directed effort to validate the work that's actually being done. Because that way, rather than having a report that these are bugs that another developer wrote, it's every developer saying, hey, I worked on session handling. These are the bugs that are related to the work that I directly did. This is how I can improve my day-to-day, which becomes relevant for their work. Now, I'm not saying pen testing is useless. I'm just saying it has 2 different functions. And it's a choice that you can say, I'd like to only have it from a compliance due diligence perspective and the attacker perspective, which is important. But you can also use it to empower your developers to give them a better look at the work they're actually doing so that they can improve. Final point, development lifecycle. implies death. I come from a pen testing background. One of like the big wins that I would give to companies, or like the big, here you go, was these are the systems that you are actually using, which should not be a big shocker, but it often is. I cannot tell you how many companies have 3 or 4 different login systems, 3 or 4 different CRMs, 3 or 4 different whatever it is with live data on them that haven't been maintained because they just like live there in that 90% legacy, or I think I said 99% legacy of like, dead children and like leviathans and scary. So when you're looking at development lifecycle as a developer, what happens when your system is no longer relevant? When it comes out of production, how does that affect the configuration? How does that affect the integrations? Who finds out? If you're deploying something and you're expecting a set of assets and all of a sudden they're gone, you're going to have to change, configurations, etc. That's probably a good thing to know. But when we're looking at agile and continuous integration, I've been really, really shocked to see that death, which I don't know if it's death or it's like dismantling or whatever the case may be, has kind of fallen away from that idea, where a lot of security is in those systems because they're still alive. They can still talk to your back end. And if they're no longer giving the love and attention from your developers and your DevOps, but they still have an open line of communication, that's where a lot of the big nasties can actually swim in and bite you. So as a developer, it is an important question to say, hey, we're switching to framework X. We're switching to this architecture. Let's make sure that somebody, and it may not be the autonomous team of awesome buzzwordy, let's make sure that they make the knowledge, like, the informed decision that, hey, we're not going to take that other system offline because I can't even think of a good reason, so I'm not even going to try. But make sure that that knowledge doesn't live in that autonomous team by itself. If you want to have 3 CRM systems that serve no purpose, more power to you. I have no idea why. But let's make sure that that type of thinking and that type of knowledge is something that actually lives outside of just the one bubble of the people that know. Because that is the type of thing that keeps you up 3 in the arm. That's where burnout comes from. And that's where a lot of the security, the business doesn't care about security. I would argue that most of the time they just don't know. And a part of that knowing is making sure that the work that's already being done is actually visible. So it's looking at how can I make sure that the work that I'm doing is communicated. It's not fancy, but it means that you'll actually get minutes to actually improve. That's all I wanted to say. I've talked about a lot of standards, and a lot of them come from OWASP, and a lot of the ideas aren't my own. So if you look at OWASP, there are a lot of good people. I don't have the names, but I'm going to give them to you, Sam, so that you can put them in so that they can get credit, because like I said, I've been enormously privileged to work with a lot of good people. But I'm going to put up a lot of good links, and I'll give them to Sam so that people can get credit, and so you can kind of copy paste and steal with pride, because a lot of it's really, really good information. You can always write to me on Twitter if you have questions. I tend to answer. I've also told Sam that I think secure development is cool. And I am once again trying to teach myself how to program. So I'm taking a Go course this summer. So, if you want to learn security and you're like a Go developer that wants to like just listen to me cry, we may be able to like, hook up. Anyway, so if anyone has any questions, I will just sit here and try and answer them to the best of my ability.
Perfect. Thank you so much, Siren. It looks like we've got a lot of thank you very muches, but no other questions coming through. So I think that is a wrap, unless something pops in, and then I can stop wrapping up. But thank you so, so much. I really enjoyed that. And we actually had Germanico give an OWASP top 10 proactive controls on our first session. So have them go back and sort of watch that if you haven't watched it already. But again, hopefully this is not the last time we have you on the Secure Developer. And again, thank you so, so much for getting involved.
Thank you so much.
So for everyone watching, as I said, this will go live on our website in a few minutes. Just give me 2 minutes to do it. Our next session will be in 2 weeks, and we are going to be talking about cloud security and the myths around it. So if you're interested in that, please sign up. You can find everything on thesecurebetter.com. If you enjoyed it, please share, shout, join the community. As we said, this is a vendor neutral community, so we really just want to enable developers to be more secure. And it is actually brought to you by Sneak, so a huge thanks to them. And other than that, I think that's a wrap. If we have no other questions, if you would like to reach Siren, there's a few of those. We'll add all the links and everything in the show notes, but she's on Twitter. I think that's the easiest way to get you, right, Siren?
Yes, I will also join the Slack. It's been on my to-do list all week, and I haven't done it, but I'm going to do it. I swear. So I will be joining the Slack community like right after this.
Perfect, and you can catch up on all the chat that happened during the session. But thank you again so much, and I hope everyone enjoyed that, and we'll see you in 2 weeks' time.
Bye, guys.